Okay, everybody. I'm going to show you how to do stuff with matrices on your CAS calculator today. So if you've got your CAS, please get it out. Alright, so once you've got your CAS calculator, you'll see that there's a button here next to a book. Sorry, a book. Book. Yep. The button next to the book. Okay, so you press that button, and then you'll see that there are some options that involve matrices in the middle. Okay. So today we just need the 2x2 one. So grab that one, and just like that, you have got a 2x2 matrix. Thank you. Yeah. Okay, so once you've got this thing there, I want you to type in this very specific matrix. We're going to give this a name in a moment. So it's got ones on the main diagonal and zeros everywhere else. Is that too small? Yeah. One moment, please. Okay. All right. Once you've got that, you need to enter in another matrix as well. So go back to the same place. And let's just put in any four numbers, okay? Yep. So choose any four numbers in the second matrix. And once you've typed everything in, press enter. Now I've written two matrices next to each other like this. What operation do you think we are doing here? We're doing matrix multiplication. Okay, once you've done that, I want you to reverse the order of the matrices. So before we put our made up one on the right, this time I want you to put it on the left. Okay, what happened? Stayed the same. Okay, so this is where you start taking some notes. So this matrix with ones on the main diagonal. Jason, Harry, Kai. This matrix with ones on the main diagonal and zeros everywhere else, this is called the identity matrix. All right, we'll give it a symbol, capital I. Can you guess what the I stands for? Yep. Okay, and it has a very, very nice property. For any matrix A, if I multiply by the identity matrix, it stays the same. Okay, so on my CAS, I use the numbers 10, 11, 12, and 13. And you can see that nothing changed, and you will have seen on your CAS, whatever matrix you put in, it also didn't change. Okay? All right, so have you got that down? Okay, year 11s. I want you to return to your calculator now. This time what I want you to do is I just want you to put in one matrix. And this time I want you to press the power button. So if you've forgotten what the power button is, it's the caret symbol next to the x squared. So it's this particular button here. So you press that, and then you'll see, sorry, it's a bit slow. Yeah. Yeah, it's my lap, so I'll turn it off. Okay, so put in the matrix, put in a power, and this time I want you to put -1 there. Can't see? Okay. All right, so those of you who do have a charged CAS calculator, you can key in any matrix. I suggest just use this one. And put a power to the -1. And then what I want you to do is take the matrix that you got as an answer and multiply by the original matrix. Watch what we get.
Whoa, that was so weird.
All right, and if I swap the order, Jason, can you move here, please? Move now. Okay. What happened? Okay, something spooky is going on here. When I took a matrix and found its inverse, and I multiplied back by the original matrix, what did I get? What's the name of this matrix here? Yeah, so we just introduced a name. This is called the identity matrix. So it looks like if I take the inverse of a matrix, multiply by the original, I get the identity matrix back. If it feels like I'm plucking things out of thin air, I am happy to accept that charge. If you were doing a course at uni, I would develop a lot more theory around this. But in general maths, we kind of just do calculations with matrices. So hopefully you've got this already on the identity matrix. So if I write a -1 on top of a matrix like that, this is called the inverse of A. And it has the property if I multiply A by the inverse from the right or from the left, I get I, where I is the identity matrix 1, 0, 0, 1. Okay, I know it's a little bit theoretical today, but are you feeling okay? Okay? Most of this stuff is on the calculator. All right, let me now explain why we are doing this. To trip down the memory lane to something very early on in the year. When we first met, very early on in the year, we solved simultaneous equations using 3 methods. The first method was substitution, the second method was elimination, and the third method was just using the CAS calculator. Today, we are going to use matrices to do it. Now, here is an example. Let's suppose I gave you these 2 equations. If I say solve simultaneous equations, what does that mean? What am I trying to do? Solve for x and y, which make both equations true. Okay? Now, watch this. I'm going to write the equations like that. You may need to convince yourselves that if I multiply these 2 matrices together, actually I'll just do it very quickly. If you're seeing this for the first time. So this is a 2 by 2 matrix, this is a 2 by 1 matrix. So my answer is going to be a 2 by 1 matrix. The first row will be 2 times x plus 3 times y. The second row will be 5 times x plus 4 times y, which is 2x plus 3y and 5x plus 4y. Okay, you don't have to write that. And then I'm saying the first row is equal to 9. The second row is equal to 1. So are you convinced that these 2 equations are now represented in this matrix equation here? Okay, so if you're not convinced, multiply the matrices out. Okay? All right. I'm going to call this first matrix capital A. I'm going to call the second matrix capital X, and I'm going to call the third matrix capital B. So I've got a new equation now. Capital A times capital X equals capital B. Okay, we're going to use this property. If I multiply a matrix by its inverse, I get the identity matrix. So if I multiply both sides by A inverse, I will get this. Is that okay? So I've multiplied by A inverse on the left.
Sorry, man.
Aye. Okay. So A inverse times A. What's that? You wrote it down earlier. I. Okay? I multiply these two matrices together, I get I. Alright, keep your notes open. What happens if I multiply by I? Nothing changes. Okay? So this is where we are now. Think about it this way. You see, I wrote my system of simultaneous equations using matrices. So if I can find this middle matrix with lowercase x and lowercase y, I'm done. I've solved the system because I have the two numbers that I need. Now, I've got an equation that tells me what capital X is. So if I want to solve this problem, ax equals b, my solution is going to be this. So you don't have to write this out every single time. If you know this, you can go straight to here from now on. Yes, Jason.
If you went to like find a mass equation, and I mean like a new one.
A new equation.
You know what I mean?
Discover something new?
Yeah.
Yeah.
How much would you get paid? Would you get paid?
Well, if people were interested in your research, you might get funded. It all depends.
Who do you know like most recent ones?
So usually if you're a mathematical researcher, you work for the government or for a university, maybe the private sector as well. So it's all up to them. If people care about your research, you'll be able to make money. But if people don't care about your research, you've got to find an equation that people care about. Yeah. Okay, so this is where we were just now. So I'll write out the matrices as well, just to make it really clear. So remember, we were trying to solve this system. So if I rewrite the first equation using this second form, the middle matrix xy is going to be the inverse of the first matrix times the second matrix with 9 and 1. So now I want to invite you to chuck this into your calculator and see what happens.
Whenever somebody gets sent out to this class, we just start using a bunch of crazy words so that they get scared.
No? Okay, the second matrix, I need to show you how to put it in. So this time, you don't want to use the button with 2 rows and 2 columns. You want to use this one. You see that one has only got 1 column, so use that one this time. want you to stay here, Jason. Okay, so those of you who have a CAS calculator, did you manage to get this result?
Yes.
Yep. Okay. So on your assignments, I actually give you a question just like this. I give you two simultaneous equations. I ask you to set up the matrices, and I ask you to find the solution. Okay? So would you like me to do one more example with this?
No, go for it.
Sorry, Mickey? Yeah? Okay. Alright, so we'll do one more. Okay, why don't you tell me the two equations this time? Just make some equations up.
6x plus 17
Yep. Yep, pick a number. Yep. We need two equations. Yep. Mm-hmm. -1. Okay. All right. Step 1. Set up your matrix equation. Ax equals b. All right. Let's start with the middle one. What's going to go in the middle for capital X? Not quite. So I'll show you the example from before. What goes in the middle? X and Y. Alright, what about B? Right? And capital A? Okay. Notice that the order of numbers is staying the same because I've got X and Y lined up correctly. Okay, so when I multiply these two matrices, the order will stay the same here. Okay? Once you've got this, you can just write this straight away. So remember, if AX equals B, then X equals A inverse times B. I need to center the page. Which way do I go? This way? Yeah. Sorry. Okay, and at this point, now you just got to use your CAS calculator. So, this is being recorded, yes.